Now that we have covered all of the major objects of the inner solar system, we want to move on to the outer solar system. But before we can do this, we must cover the dividing line, the asteroids. Most asteroids reside in the asteroid belt, but some reside closer to Earth. These objects can range in size from car-sized boulders to 600-mile-wide dwarf planets. There have been, and are, many missions to these asteroids, so let's take a look. Let's start with the OSIRIS-REx mission from NASA. This mission launched in September 2016 and headed off toward the 1,800-foot-wide carbonaceous asteroid Bennu. On December 3rd, last month, the probe arrived on the asteroid. Currently, the probe is in orbit around Bennu, surveying it to find a good site to land and retrieve samples. Once it has found a good spot to do so, it will bring a piece of Bennu back to Earth with it. There are a few reasons that the asteroid Bennu was chosen over others. First off, Bennu is a carbon-rich asteroid and a relatively old asteroid. It has been kicking around the solar system since its formation. Because of this, Bennu holds a record of what conditions were like in the early solar system that has eroded away on Earth and other planet-sized objects. Also, Bennu may hold some precursor organic molecules that could have been used to start life on a planet like early Earth. If this is true, then it will support the idea that asteroids impacting the newly formed Earth gave it materials to produce life. Earth's oceans may have also arrived in this fashion, and the study of Bennu will help to determine whether or not this was the case. Finally, Bennu is a near-Earth asteroid, and has been deemed as a potential risk for Earth in the future. The study of this asteroid now will allow a more accurate view of its future path, and an analysis of its features that could be used for asteroid deflection. Next, we move on to JAXA's Procyon and Hayabusa 2 missions. These missions launched together in 2014. Procyon, scheduled for a flyby of the asteroid 2000 DP-107, failed when its ion thrusters wouldn't turn on. Hayabusa 2, however, has been working as planned. With a similar mission to NASA's OSIRIS-REx mission, Hayabusa 2 is traveling to the carbonaceous asteroid Ryugu to fetch and retrieve samples. Remember that Bennu is also a carbonaceous asteroid. So, similar insights about the origin of life and water on Earth will be gained. Next is NASA's Dawn mission, which just retired in November. This mission launched in 2007 and orbited Vesta, then settled into an orbit around Ceres. Ceres and Vesta being the two largest asteroids in the asteroid belt, this was an important mission there. Accomplishing a 2-for-1 by orbiting and studying two separate objects, Dawn was an amazing mission. Through its observation of Vesta, it connected a type of meteorite found on Earth to the asteroid. This means that we don't need to go to Vesta to collect samples. The samples have come to us. Moving on to Ceres, Dawn found water and organic molecules, supporting the panspermia hypothesis of the origin of life and water on Earth. Panspermia is the idea that life arrived on Earth from life-carrying asteroids that I discussed for the OSIRIS-REx mission. Next is NASA's DART mission. This mission is a demonstration of how we could deflect an asteroid from hitting Earth. The binary asteroid system Didymos is the target of this mission. In the early 2020s, DART will ram itself into the smaller body at 6 kilometers a second. Astronomers will then measure how this affects the binary orbit of the two bodies to see how much change in motion the spacecraft can muster. This display employs the kinetic impactor method of asteroid deflection. It isn't very high-tech, it is based on Newtonian physics. If you throw something heavy and fast at another object, its motion will change. There are more advanced methods of asteroid deflection, but those are a topic for another video. Now we move on to Planetary Resources, a private company that plans to make money off of asteroid mining. Right now, the company is in the data collection phase, planning missions to analyze many different asteroids that look promising for resources. The first mines would be mines to collect ice. Water is a very valuable resource for space travel. Any living thing needs it to survive in space, and it can be turned into rocket fuel through electrolysis. The collection of ice will bring about cheaper costs for living in space. After that, Planetary Resources plans to mine metals as well. A lot of rare earth metals like gold or platinum are present in asteroids. While Earth has a much higher mass than the asteroid belt, and therefore a much higher amount of these materials, they are locked away in the mantle and core where we can't get them. Asteroids are pretty much all surface because they are so small. This allows the easier collection of resources. The final possibility for the asteroid belt is a manned mission to an asteroid. All of our asteroid exploration so far has been unmanned, but as people continue to expand into space, it seems inevitable that humans will one day set foot on an asteroid. One proposed mission was to lug a small asteroid into Earth orbit so that astronauts could reach it as easily as Luna. Another was to make the long-haul trip to Ceres. The reason that anyone would want to do any of that is because humans can pick up on things that robots can't. We have discovered a lot through our use of space probes, but human study could result in many more discoveries. All in all, the asteroid belt has been host to many interesting missions and will be host to many more. Being the fossils that display the conditions in the early solar system, as well as being a great source of resources, the asteroid belt is very useful. In the future, we may live there as we mine it for resources and make space stations, but that is also a video for another time.